We're now on to letter C of the 1999 number 3 kinetics question. For response, for each reactant in this reaction. So on the last problem we just figured out that in terms of bromine, this reaction is first order and it is second order with respect to nitrogen monoxide. And so they ask us to write the rate law that is consistent with the data. So since we know that this is first order and second order, we're going to follow the traditional format. So the rate law ends up being written as rate equals K, the rate constant. Don't need to put the number in there. And now we have bromine. Since it's first order, we don't need to put any additional exponent. NO is second order, and so we'll put a little superscript exponent 2 there to represent second order. By the way, not a question on here, but something that you could also be asked is what is the overall order for the reaction. So if they ask you what the order is for the entire reaction, all you would do would be to add the orders of each part written in the rate law. And so we would say that overall this is a third order reaction. The follow-up to that question is to find the value of the specific rate constant K and specify units. So we're going to do two things here. Both of them involve the rate law itself. We are going to first, on the next page here, we're going to take one experimental trial. So we're going to use experimental trial 1. We're going to take its data and we're going to put it into the rate law that we just wrote. And that will help us solve for the rate constant. And then I'll show you how to find the units for K. So I'm just going to copy this over on the next page and we'll keep working from there with experiment 1's data. There's our rate law rewritten, and now I'm taking the information from experiment 1, and I could do this for experiment 2 or 3, and K will come up the same number, so that part doesn't matter. The rate in experiment 1 was 3.24 times 10 to the negative 4th, and units for rate here are molar, which is molarity per second.
Nancy Happy, please call 1621. Nancy Happy, 1621.
Hopefully they contact Nancy. Okay, so we're solving for K. Bromine is 0.012 molar in experiment trial 1, and it's to the first power because it was first order. And then the nitrogen monoxide is second order, so we'll be squaring that number. Okay, so now you can take the calculator out. We'll be solving for K, and the work then is just regular algebra. Nothing too fancy to be done there. Notice I'm writing the units in. We're going to kill two birds with one stone here, so I'm going to grab my calculator and we'll punch this in. Okay, so punching in the numbers in the top. And our rate constant K is 105. Looking at the data, all the data had 3 significant figures, so our answer should have 3 significant figures. So K equals 105. And now for the second part, which is for letter I, I'm sorry, actually, technically, there we go. Okay, so there's C2. Alright, so the second part of this, they also want us to specify the units. So we need to carefully walk our way through these units. I'm just going to first write them out all together. As they would appear. So that's just transposing this down below. And now it's a careful cancellation process. So molarity over molarity cancels out to 1. And I'm left with 1 over seconds divided by meters squared, or molarity squared. If I write this out then, the way that you're probably going to see it is like this. So in other words, 1 over molarity squared times 1 over seconds are the final units for K. And this is traditionally a question by itself. What are the units for K? And that's how you do it. Okay, so we're going to go on to letter D now. Letter D is about reaction mechanism. Just to show you the question briefly. And I think we'll just work on this one actually. So we get this proposed mechanism for the reaction, and the tie between the rate law and the mechanism is that the orders should indicate which components react prior to and during the rate determining step, which is the slow step, which is also the step that has the greatest activation energy. Based on my rate law, what I can conclude is that 1 bromine molecule and 2 nitrogen monoxide molecules, and I'm getting this 1 and 2 from the 1 here and the 2 there, 1 bromine and 2 nitrogen monoxides are involved in the steps leading up to and including the rate determining step, which is also the slow step. In this case, the slow step is the very first step, and if I look at the reactants, what I see is 1 bromine, which matches our rate law, but I only see 1 nitrogen monoxide. Here, our rate law indicates 2 nitrogen monoxide should be present at this step, or if there were any before. So, if I was just going to write the rate law based off of this information, this proposed mechanism, my rate law would look like this. And so, based on this, I would only think that the reaction is first order for bromine and first order for nitrogen monoxide. So, is this mechanism consistent with the given experimental observations? Well, our experimental observations lead us to this rate law, and so our first answer is no. Please answer the questions directly, so no. And then we want to justify our answer. And so now we can explain things in a variety of ways. And so in this case, what we're going to say is that the reaction above is not consistent with our rate law. And now we have to explain it. That's not enough information. That's just confirming what the no meant. But now what we're going to say is that the proposed mechanism should have a rate law of, and now I'm just going to write down what that proposed rate law should have been if it had been true. And our rate law indicates that 1 bromine and 2 nitrogen monoxide molecules should have been involved in the steps leading up to and including the slow rate determining step. This mechanism is incorrect. This proposed mechanism is incorrect. So I'm just going to say one quick thing here that goes in general. When you're answering these types of questions where they want you to justify your answer, you can typically justify it mathematically if there's a mathematical formula to prove the result, or you have to explain it in words. And when they're marking these, what they're looking for is the correct information. And if you're not quite sure which correct information they're looking for, you can put down several different answers that all go towards that same answer. Just keep in mind you cannot contradict yourself and you cannot provide incorrect information in your explanation. So it's okay to go fishing a little bit so long as everything that you're saying is accurate and appropriate to the problem. Okay, so that ends this this particular problem. The other problems that I'll be doing, I'll try to find one that starts out with graphical analysis, and so we'll take this approach from that, and then if we can find one that starts with a mechanism, we'll also run through that online. So that ends the 1999 AP for response question number 3 on kinetics.